Um, Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Haloalkanes and Haloarenes. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them. Mm, Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience education application. Uh, so please install our Sapience education application whose link has been provided in the description. So here it is told that on treating a mixture of two alkyl halides with sodium metal in dry ether, 2-methyl propane was obtained. The alkyl halides are. So the simple rule is that when an alkyl halide, which is Rx, is reacted with another alkyl halide R dash X with sodium metal in the presence of dry ether, then it forms the alkane, which is R dash. So simply the two alkyl groups which are linked with the halogen atom will be linked with each other, and then it will form 2NaX, which is the sodium halide. So this type of reaction is called as Wood's reaction. Wood's reaction. So here the alkyl the alkane which is formed, that is 2-methyl propane, 2-methyl propane, which is like this. So it is 2-methyl propane. Now how it can be formed? It can be formed from by using CH3 CH CH3 Cl and plus CH3 Cl plus 2Na, and then it will form in the presence of dry ether. Then simply this methyl group will be linked with the isopropyl group. Since why it is the isopropyl chloride, I can tell. So this isopropyl group will be linked with the methyl group. Then it will form the 2-methyl propane. 2-methyl propane will be formed, and 2-sodium chloride, 2NaCl will be formed. So hence the mixture of the two alkyl halides, it contains chloro, which contains 2-chloropropane, or I can say isopropyl chloride. It is the common name, but its actual IUPAC name is 2-chloropropane. And CH3Cl, I can tell it is chloromethane. So chloromethane should react with 2-chloropropane, then only the required product, which is 2-methyl propane, will be formed. So option 3 is the correct answer. Then here it is told which of the following statements about benzyl chloride is incorrect. Now benzyl chloride, it is C6H5CH2Cl, or its structure is actually like this, CH2Cl, which is called benzyl chloride. So now benzyl chloride, it is more reactive. It is more reactive than any uh, yeah than any alkyl halides. Than any alkyl halides. Since why? Since the benzyl carbocation, which will be formed by the removal of one chloridan, since the C6H5CH2 plus, which is the benzyl carbocation, benzyl carbocation, which is formed by the removal of the chloride ion, is stabilized by re resonance. Is stabilized by resonance, and hence this benzyl chloride, this C6H5CH2Cl, which is the benzyl chloride, can easily give can easily e- easily give SN1 reaction, which is the nucleophilic substitution reaction. So here it is said that it is less reactive than alkyl halide, which is a wrong statement, since why benzyl chloride is more reactive than any alkyl halide. So option 3 is the incorrect statement, so it is the correct answer. And in the option 1 it is said that it is a lacrimatory liquid and answers Bellstein test. Yeah, it will be true, since why um, Bellstein test Bellstein's test given by is given by any organic compound which contains halogen, by any organic compound containing halogen. So now this benzyl chloride, which is C6H5CH2Cl, it it contains chlorine as the halogen, so it will give the Bellstein test. Hence, the first statement is true. And the second statement is that it gives a white precipitate with alcoholic silver nitrate. So with benzyl chloride, if the alcoholic silver nitrate is used in presence of alcohol C2H5OH, then it will form a white precipitate, which is AgCl. So AgCl will be formed, and it will form uh, C6H5CH2NO2. So here now this silver chloride which is formed, it is a white precipitate which will be formed. Hence the second statement is also true. And fourth statement is it can be oxidized. It can be oxidized to benzaldehyde by boiling with copper nitrate solution. Yeah, that is also true, since why when benzyl chloride, it reacts with copper nitrate solution, then it is oxidized to benzaldehyde. Yep. So it means that only the third statement is wrong, so it is the correct answer. Then it is said that use of chlorofluorocarbons is not encouraged because because since why they eat away the ozone layer in the atmosphere. So third option is correct. Since why chlorofluorocarbons chlorofluorocarbons, which is like this, which is like CCl2F2 or CCl3F. Okay, so all these are called chlorofluorocarbons. It means that which has got chlorine also and fluorine also, which is attached to the same carbon. So chlorofluorocarbons are used for air conditioning in refrigerators, are used for air conditioning in refrigerators, and which cause the ozone layer depletion, which causes the depletion of the ozone layer, depletion of the ozone layer. So since it eats up the ozone in the atmosphere, so the use of chlorofluorocarbons is not en encouraged. Chlorofluorocarbons should not be used if we want to protect the ozone layer of the atmosphere. So option 3 is the answer. Okay. Then here it is said that ethyl chloride, ethyl chloride, it means that C2H5Cl on heating with AgCN forms a compound X, forms a compound X. The functional isomer of X is. So now AgCN, which is silver cyanide, it will give the isocyanide as one of the Nc minus ion, which is the isocyanide ion as the nucleophile. So here isocyanide is the nucleophile. So it will attack this chlorine, the and this Nc minus, it will attack here, and the chloride ion will be removed, and the Cl minus ion will be linked with Ag plus, and it will form AgCl plus, it will form CH3CH2 Nc. So this CH3CH2 Nc, it is the required compound X. Now we need to find the functional isomer of X. So now isocyanide is a different functional group with respect to the cyanide group. So it means that CH3CH2Cn will be the we can call it as propane nitrile, propane nitrile, or I can say it is ethyl cyanide. So and CH3CH2Nc, it is called the ethyl isocyanide. So it means that the functional groups are not the same. So this propane nitrile, which is CH3CH2Cn, it is the functional isomer of X. So it means that option 3 is the correct answer, which is C2H5Cn. And here it is told which of the following haloalkanes is most reactive. Now, the first one, it is 1-chloropropane, 1-chloropropane, so it is CH2, CH2, CH3. So it is 1-chloropropane, and the second one is 1-bromopropane, 1-bromopropane, which is CH3, CH2, CH2, Br, and the third one is 2-chloropropane, 2-chloropropane, which is CH3, CH2, or CH3, CH2, CH3. Then here we'll have 2-chloro, so it is 2-chloropropane, and then fourth one we have 2-bromopropane, CH3, CH3, which is 2-bromopropane. So here we have to use the order of the reactivity. So now, therefore, the order of the reactivity of alkyl halides are given as Ri greater than Rbr greater than RCl. So it means that alkyl iodide is more reactive than alkyl bromide, which is more reactive than alkyl chloride. So it means the nature of the halogen, or the nature of the halogen atom, uh, is one of the fa- uh, one of the factors on which the order of the reactivity of alkyl halide will depend on. So the order of the reactivity of alkyl halide, it depends on the nature of halogen atom. And also the 3-degree halide, the 3-degree alkyl halide, or I can say tertiary halide, tertiary halide is more reactive than 2-degree halide or secondary halide, and which is more reactive than 1-degree halide or the primary halide. Primary halide. So here, as you can see, that this 1-chloro propane, it is a 1-degree halide, so it is less reactive, and it has chlorine also, so it is even less reactive. And second one is also 1-degree halide, but here since bromine is attached, so the second one is more reactive than the first one. And in the third third one, here we have a 2-degree halide, but here we have chlorine, so it is less reactive. Okay. And in the fourth one, it is a 2-degree halide. Fourth one, it is a 2-degree alkyl halide, and here bromine is attached, so it means that it is more reactive than the 2-degree halide with chlorine. So it means the fourth one is the most reactive haloalkane. So option 4 is the correct answer. Then here it is told that the methyl bromide, methyl bromide CH3Br is converted into ethane CH3CH3 by heating it in ether medium with by heating it in ether medium with sodium. Here we can use sodium in the presence of dry ether. Then it will form CH3 and 2NaBr, which is also called as the Woods reaction. Since why, if we use the same alkyl, uh, if we use the same alkyl halide, then it will react with sodium in the presence of dry ether to form RR. So it means the same alkyl group will be attached with itself to form an alkane, and then it will form sodium halide. So it means that, so if we want to convert the methyl bromide into ethane, this is the methyl bromide which we want to convert into ethane. It can be done if we use sodium in the presence of dry ether m- m- medium. So option, so sodium should be used. So option 3 is the correct answer. Then here it is said that the catalyst used in the preparation of an alkyl chloride by the action of dry HCl on alcohol is. So here it is told that the catalyst which is used in the preparation of an alkyl chloride, so it will be anhydrous ZnCl2, since why when an al alcohol reacts with dry HCl in the presence of anhydrous zinc chloride ZnCl2, then it will form alkyl chloride. So in the preparation of alkyl chloride from a- from alcohol, here the catalyst used is anhydrous zinc chloride. So it means that option 1 is the uh, 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 no, option 3 is the correct answer. And here FeCl3 and AlCl3 can't be used. FeCl3 or AlCl3 is a, since why they are Lewis acids. Since Fe, since why the Fe3 plus ion and Al3 plus ion, they are Lewis acids. So since they are Lewis acids, so they will favor, so they will favor electrophilic substitution. They will favor electrophilic, which is E plus. They will favor electrophilic substitution reaction uh, rather than nucleophilic substitution reaction, rather than nucleophilic substitution. But anhydrous zinc chloride can be used. Uh, but the anhydrous zinc chloride is a is a polar medium, so it will favor the nucleophilic substitution only. So the anhydrous zinc chloride is a polar medium, so it favors nucleophilic substitution reaction only, uh, by dissociating the H plus the Cl, no, yeah, yeah. So here the anhydrous zinc chloride is a polar medium, so it favors nucleophilic substitution reaction by dissociating the HCl into H plus ions and chloride ions, H plus and Cl minus ions, and hence this Cl minus ion, which is the chloride ion, it acts as the nucleophile. It acts as the nucleophile which attacks the OH group, which attacks the OH group in the alcohol, OH group in the alcohol. Since 5 from, if anhydrous zinc chloride is used, so it will dissociate this HCl into H plus ion and Cl minus ion, and this Cl minus ion it will attack here, and this OH minus ion will come out and it will form RCl. And here copper also can't be used. Cu copper can't be used since it is an since it is an oxidizing agent, since it is a very good oxidizing agent, and it will and so it will oxidize So it will oxidize the alcohol ROH into the aldehyde group, into RCH. So it will convert the alcohol into aldehyde. So copper can't be used. So hence option 3 is the correct answer. Then here it is said that in the reaction, in the re reaction RX, which is the alkyl halide, it reacts with alcoholic potassium cyanide, and then it will form the product A, and this product A, it will react with dilute HCl to form the product B. Now we have to identify which one is the product B which has been formed in the final step. Now this, from this alcoholic KCN, it will dissociate into K plus ions and cyanide ions, CN minus ions. Now this CN minus ion, it is acting as a nucleophile. It is acting as a nucleophile. So here also there will be nucleophilic substitution reaction. So this CN minus ion, it will attack here, and then X minus ion will be removed, which will combine with K plus ion to form potassium halide, and it will form RCN, which is the compound A. It means that it will form alkyl cyanide, or I can say alkyl or alkane nitrile. It will form alkane nitrile, and which will again react with dilute HCl. It will react with dilute HCl to form the carboxylic acid, RCOH, which is the required compound B. So it means the required product B, it is obviously a carboxylic acid. It is a carboxylic acid. So it means that option 3 is the correct answer. So here the mechanism of this reaction, if we want to know, that is somewhat like this. The alkyl halide will react with the cyanide ion, and this cyanide ion will attack here, then X minus will come out, then it will form RCN, and then when dilute HCl is used, it means that it is called as acid hydrolysis. It means an aqueous solution of an, so when dilute HCl is used, it means an aqueous solution of an acid is being used. So it is called acid hydrolysis. So here H2O is acting as the nucleophile. So this H2O, it has got lone pair on the oxygen atom, so it can act as a nucleophile, it and so it will attack here. So it will attack here, and the cyanide ion will be removed, and then it will form RCN. Actually, what is happening here, we have the cyanide ion CN group. Now when H2O will attack here, then the pi electrons in the cyanide group will go to the nitrogen atom. Then it will form RCN minus OH2 plus. Now what will happen here? From here H plus ion will come out, and it will attack here, and then it will form RCNH, and we have OH2, OH. And then again further this RCNOH, it will again react with H2O in the presence of an acid. Now again this lone pair on the oxygen atom, it will attack here, and the pi electrons, the okay, so here it will be NH, sorry, this hydrogen H plus will come and link with N minus here, so it will form NH. Okay, then this H2, it will again it will again attack here, and the pi electrons will come on the nitrogen atom, and then again it will form RCOH2 plus and OH, and then NH minus. From here also again one more H plus will come and it will attack here. So then finally, so here one H plus is removed and one H plus is added. Then it will form RCOH, OH and NH2. And then here this lone pair on the oxygen atom, it will come here, and the NH2 group will be removed in the form of NH3. Since why, from here the H plus ion will come out and it will link with the NH2 group, then it will form RCOOH plus NH3. So it means in the final step the carboxylic acid only will be formed when the alkane nitrile, which is RCN, it is reacted with dilute HCl. So carboxylic acid is formed. So option 3 is the correct answer. Okay. Then here it is said that an organic compound which produces a bluish green colored flame on heating in presence of copper is. So it is also called as the Bellstein's test. Bellstein's test. So here an organic, if an organic compound, it is heated in the presence of a copper wire, then it will form a bluish green flame. It will form a bluish green flame if, okay, if the organic compound contains a halogen. If it contains, if it contains a halogen, then only it will give the Bellstein's test. Since why, the halogen will react with the copper and one copper halide is produced. So when copper halide is formed, the color of this copper halide compound is, it will give bluish green colored flame. So this copper halide will be formed only if this organic compound contains some halogen. So now in the first option we have chlorobenzene, which is C6H5Cl, I can say. So it contains the halogen, that is chlorine, and hence it will obviously it will obviously give this Bellstein's test. It means that it will form a bluish green flame on heating with copper. And then in the second one we have benzaldehyde, which is C6H5CHO, which will not give the Bellstein's test, since the benzaldehyde is not having any halogen atom in it. And in the third one we have aniline, which is C6H5NH2. So here also we have no halogen atom, so it will also not give the Bellstein's test. So second one also will not give the Bellstein's test, and in the fourth one, which is benzoic acid, which is C6H5COH, and it also is not having any halogen in it, so it will also not give the Bellstein's test. Will not give the Bellstein's test. So it means that only chlorobenzene, which is C6H5Cl, it will only give the Bellstein's test. It means it will give a bluish green colored flame on heating with copper. So option 1 is the correct answer. And here it is said that benzene reacts with chlorine in sunlight to give a final product. So benzene, which is C6H6, that will react with chlorine in the presence of sunlight to give the final product. So here it will uh, proceed through free uh, radical chain mechanism. So here free radicals will be formed, and it will be of obviously a kind of chain reaction. So it will, so the chlorination of benzene will proceed through free radical chain mechanism. Free radical chain mechanism will be there. So it means that all the hydrogen, since as we know that benzene has got 6 hydrogens, C6H6, so all these hydrogens will be re replaced with chlorine in 6 steps. So in in every step, it means one by one, all the hydrogen atoms in benzene will be replaced by chlorine. So it will form Cl, Cl, Cl like this. So it will form C6Cl6. So option 2 is the correct answer. So the IUPAC name of C6Cl6, it is called benzene hexachloride, or it is actually the common name of C6Cl6, which is benzene hexachloride, and in short, its short form is BHC. Okay, so 3H2 should re react. So free radicals are formed, and one by one, all the hydrogens will be replaced by chlorine. So in its common name is benzene hexachloride, and IUPAC name will be hexachlorobenzene. Okay, so it means option 2 is the correct answer. Here it is said that how many chiral carbon atoms are present in 2,3,4 trichloropentane. So if we take pentane, this is pentane, and we have 2,3,4 trichloropentane. So here we will have H, 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 and here we have CH3, CH3. So on this carbon, the 4 groups which are attached on 4 sides are not the same. They are, so all 4 groups are different for this carbon. So it is an asymmetric carbon or a chiral carbon. And for the middle carbon here, we have 2 similar groups which are attached. So hence it is not a chiral carbon. And in the last one, in the left end, here we have one carbon which has all the 4 groups which are different. all the four groups which are attached to this carbon are not the same. So it means this carbon is also a chiral carbon or an asymmetric carbon. So it means that here we have two chiral carbons. So here we have two chiral carbon atoms which are present in 2,3,4 trichloro-pentane. So option 2 is the correct answer. Then here it is said that decom decomposition of benzene diazonium chloride. Decomposition of benzene diazonium chloride, which is N2 plus Cl minus. So its name is benzene diazonium chloride. So it is reacted with Cu2 Cl2 with HCl to form chlorobenzene. It will form chlorobenzene. So and it will form N2. So this kind of reaction, when the N2 is removed to form chlorobenzene from benzene diazonium chloride by using CO2 Cl2 HCl, it is called Sandmeyer's reaction. Sandmeyer's reaction. So option 3 is the correct answer. Then it is told which of the following is an organometallic compound. So here obviously the Grignard reagent, which is of of the form RMGX, where uh, R is some alkyl group. So this Grignard reagent, it is a kind of organometallic compound. Organometallic compound. Here X is the halogen atom and R is the alkyl group, which is covalently bonded with magnesium. So magnesium is covalently bonded with halogen and with the alkyl group. Then only it is called as the Grignard reagent, and it is an example of organometallic compound. So suppose for example here in the option D, it is told that the CH3CH2, which is the ethyl group which is attached to Mg and Br to form CH3CH2Mg Br, which is the Grignard reagent. So option D is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter Haloalkanes and Haloarenes. So still any doubts if you have, then please write that in the comments section. We shall obviously clarify them. And please install our Sapience education application also, where we shall upload some important questions based on the previous year KCET exam on every chapter of chemistry, which shall be obviously helpful for your exam. So thank you everyone. Bye.